Swayam Prabha. Digital India. Educated India.
Demo on homology modeling. So, here we will demonstrate how to build a model for a protein structure from any specific amino acid sequence. As I discussed earlier, homology modeling requires several steps such as target sequence, this sequence which one you like to get the structure, and first you need to get the templates, then alignment, backbone generation, loop modeling, side chain modeling, model optimization and validation. For example, if you have a protein called human CS kinase, tyrosine kinase, with the UniProt ID, UniProt is the database for protein sequences P07947. So, we know the sequence, now the task is to get the structure. So, there are various steps involved to get the structure. First, we have to get the template, right, using the BLAST, then build kinase domain of this CS kinase, and we generate the maximum of 10 models and calculate energy score, which is lowest denotes the best model. Then evaluate the model using Ramachandran plot and report the structure similarity and visualize the structures. So, to get these structures, the prerequisites are first install and register modeler. This is software used for modeling structures using homology modeling, and we need internet for the template search as well as validating the model, and we need the tools such as PyMol for visualization and RMSD calculations and so on. Now, we will see how to build a model from the sequence of the human CS tyrosine kinase.
Now, I will give a demonstration on prediction of protein structure using modeler software. Using modeler software, we can do a homology modeling, and here the task is predicting the structure of human CS tyrosine kinase, and its UniProt sequence ID is P07947. So, it includes a few steps like retrieving protein sequence from UniProt and searching template using BLAST and building the structure based on the template. So, these are all the 3 essential steps which I am going to give demo, and to do this we have to understand how the structural organization of the protein tyrosine kinase. Here the protein CS kinase, which belongs to the SRC kinase family, has 3 domains. One is the kinase domain and then SH2 and SH3 domain, but the task given is building the kinase domain alone. So, accordingly we have to retrieve the sequence and start doing modeling. So, the prerequisites are the modeler software installed, and then the internet facility for template search and model validation, and the tools, visualization tools for visualizing the target and templates and to make a comparative statements on it using metrics like RMSD. So, first I will explain how to start searching the template for given protein sequence. So, to retrieve the sequence, go to UniProt and type the ID, and it will show the full annotation, and you search for the sequence belongs to the kinase domain. So, for that if you search kinase domain or SH2 or SH3, whatever it is. So, here you can see the region the sequence region belongs to protein kinase that starts from 277 to 530. If you click on this link, you will get the sequence exactly that is belongs to the kinase domain of the protein kinase. You can copy this and save it as the FASTA. File save as. So, use the same ID as a file name dot FASTA FASTA and save it in your preferred working directory. Just make homology or model. So, now we have retrieved the kinase domain of the sequence of kinase domain, and now as per the need for the modular software, this FASTA file should be converted into the PIR format. So, so this is the typical PIR file format shown in blue color. It starts with the command line followed by the sequence description and the actual sequence, and it ends with the star. Actually, the first belongs to the line gives the detail about the aligned code, which is very essential for modeler to read the sequence, and the same ID should be used throughout the process. And so, accordingly the user can specify any ID in 4 letter alphanumeric 4 letter to identify the sequence, and followed by in the second line the first term sequence denotes this is belongs to the target sequence, and in the case of the template it will be structure X, that is as explained here, and followed by this it has the 10 fields related to the structural detail of the protein, but for sequence it will be null. And so, accordingly we have to modify the FASTA file to make the PIR. So, you just modify this P1 comma, you can give just CYES as a keyword or 1 YES, followed by this is the sequence target sequence. So, it has to be specified with sequence followed by 10 fields 1 2 3 4 5 9 10 fields separated by 9 columns. So, we can leave these fields blank because for which the structure is not known, and it has to be ended up with the asterisk. Then you can save it as PIR. So, this is the first essential step to get ready with the target sequence. So, now we can start with the typical workflow involved in homology modeling. Now, in order to do the first step, we have to search template using the BLAST. Do protein BLAST against the PDB database, so that the homology will be searched in the PDB database. Use the FASTA formatted sequence. And here you have to select the database, the structure database PDB, and do a blast, and you can play around these parameters also in order to get some more number of hits, and do blast. So, as a result you will get the number of homology, the homologous proteins with protein structure exist in the PDB. So, in this list you can see the first hit that comes from the SRC family, even the CS kinases also belongs to the same family, and it has the score and choric average, good score, choric average of 100% and identity is about 90%. So, you can note down this PDB ID and see how the structure exists. You go to the PDB and give it. The template search is a very important task because the modeler will build based on template only. If template is not chosen properly, the result will also be ended up with error. So, it is very important to choose the template appropriately. So, even though the score and choric averages are good for the first hit, the ranked 1 based on the E value, this is belongs to Gallus, but the task given for us is building structure for the human protein kinase, human CS kinase. So, in this case we have to see carefully whether any of the other hits in the blast belongs to human or exist. If you see the second hit, which is also equivalently good, but only the identity percentage identity is less, but still the 89% is good. So, if you go to MXO and search, go to PDB and see how this structure exists. See here, it has two chains, A and B belongs to the protein kinase domain, and it has the ligand bounded conformation, and this is also equivalently good. So, in this case which one we will take, whether the template has the good identity, the ranked first as per the blast result, or the second one which is belongs to the human. So, both are equivalently good for model building, but still if you visualize using some visualization tools, for example Chimera, if you take, the visual inspection is very important, and in addition to the blast search results, because this blast search is based on the sequence alignment, while even the PDB the chances for having missing residue in PDB structure is high. So, in that case if you visualize the structure, you can see whether the structural information for the given template is complete or not. So, here for example, if you see MXO that is belongs to the human, you can retrieve the structure 4MXO. Just fetch. This is the simplest way to see whether the structure is having any missing residues. See, the camera will easily will tell you through the dotted lines. See, here you can see the dotted lines, that is belongs to the missing segment. So, this 4MXO is not the complete one, so we do not choose it. If you check for 3U4W, even though that is belongs to the gallus, see, you can compare now. See here, for in gallus you do not see any missing residues, there is no dotted lines. Here you can now compare and see both the structures, how identity both are, using the chimera tool, matchmaker. This is the reference structure, and another one can be the structure to match. You just click OK. See here, both the structures are identical, and you can see here the segment which is missing in human protein is present in the chicken protein. So, in this case we do not mind the 1% difference in the identity. Here the structural information is very important for model building. So, we will take the CS kinase of gallus instead of human for this task and start doing the homology modeling. So, now we have retrieved the sequence from UniProt, and we have retrieved the appropriate template from PDB. Now, target and template both are ready to do the homology modeling. So, if you go to your working directory, you will be having 3 files. First one is corresponding to the structure in PDB file format, and the 2 files fast and PA formats belongs to the sequence. Now, you can start working with the modeler software, which we have already installed in our computer using the procedure given in the modeler website. If you go to the modeler website, you can see the documentation for downloading and installing the software and to do registration also. Here in the documentation, download and installation instruction is given here. You can download the software which is compatible for your computer and install it. And the current version of the modeler is 9.19, and this is command mode. And in the documentation you can see the help manual to perform the modeling. You can follow this simple instruction to perform the homology modeling as we are going to discuss now. So, in model building there are two essential steps which is very important to discuss here is first the alignment of protein sequence with the template structure. We will call it as target template alignment. To do this, we can get the script, modular script from their website here. This is the script we have to use to perform the target template alignment, so that the sequence of our target sequence will be aligned to the sequence of the template structure. So, you can save this script as the model.py, because this is the Python script. The first step is alignment .py. So, if you look at this script, the first 4 lines corresponds to setting up the environment variable and importing the necessary modules from modular and action to perform the alignment. So, here in the next line, if you see the value to the variable file, that is belongs to the template. So, here what template we have chosen is 3u4w, that has to be given here carefully, 3u4w, and this has only chain A. If you go to the PDB site, there you can see, you can confirm how many chains this protein has. It has only one chain A. So, you have to specify the starting and ending chain names. So, here only one. So, in both first and last will have the same value, the A, and in the alignment, the next line corresponds to the sequence, where you have to specify the align code for the sequence of the template structure. So, here we will give the same ID 3u4w followed by A, in order to identify the sequence that is belongs to the chain A of the protein tyrosine kinase structure, and followed by the atom file name is 3u4w.pdb. So, that these two lines will tell modeler to consider the chain A of the template structure and for the alignment, and in the next line we will give the target sequence information, that is P07947.PIR, and the align code corresponding to the target protein is 1YES. That is what we have mentioned here. The same thing should be given here, 1YES. And here also we will specify the same, so that modeler will read these two codes and identify which is the template and which is the target. So, the output alignment file will be like target template .ali is the output file in PIR format. We can save this. So, now the script for target template alignment is ready and we can perform it using modeler. So, start modeler command mode and change the working directory using the cd command in Windows. Now, here you can use the command mod 9.18 is the command here for this version, followed by one dot alignment, the Python script file. So, it will start doing the alignment. So, once the alignment is completed, we can start doing with the model building. In the same help page, you can find the second script that is belongs to model building, and you can copy the script and save it similarly. So, in this script, if you see, similarly the first 4 line corresponding to the modular libraries, and the next line belongs to the specification of the target template alignment file, and then the corresponding the align codes. So, from the result file of step 1, we can note down the align codes and then specify here to perform model building. So, the target template alignment is the output file we got now, and if you open and see here in the alignment file, you can see the alignment in the PIR format and the align codes that is corresponding to the structure, and the align codes that is corresponding to the sequence, and both the codes you can note down, or even for safe you can copy and paste it to the new script, the next script. Here the nonce is corresponding to the structure ID. So, here what we used is 3U4WA, and for sequence that is target, that is 1YES, and the next line tells the what method is going to be used for model building and scoring. Here the DOPE scoring scheme is used to evaluate the models, and here this line corresponds to the number of models to be generated. So, this is the file called the second step model building. .py. Yeah, and we have to specify the correct alignment file also, that is target template .ali. This is the file actually we have got from the previous run, target template.ali, that is specified now, and now you can perform model building using the same command _. So, these are the two important scripts to be edited carefully in order to perform target template alignment and model building. Once this is done, and you will be getting the 10 kinase structures for the given target sequence, and you can evaluate the correctness of the model in the next step. So, we will wait for a while until this generates the 10 structures. So, now you can see the progress. It generated the 2 structures so far, that has the file name starts with the align code of the target sequence followed by some alphanumeric numbers. So, once all these 10 structures are built, we can start evaluating the models based on dope score. That will be written in the log file of the presently running script. So far we have completed the model building. In the workflow, we have retrieved the target sequence and retrieved the template structure and performed the alignment and performed the model building also, that includes backbone generation, loop modeling, everything will be taken care by model build step, that is called auto model. Next we have to evaluate the model. So, to perform this, we need a software to generate the Ramachandran plot. We can use some online tools called Rampage, for example. So, here we have to upload the selected model based on dope score and see how many residues are in allowed and disallowed regions in order to finalize the model for further work. So, the model building is almost done now. Now, we will see the log file of the model building and choose the model based on the dope score, that is written at the end of this log file. Here if you see, for the given for the 10 structures generated, the least dope score is the best one, that is somehow 3, 5, 7, yeah. The 7th model is the best as per the dope score. If you take the 7th structure now to visualize using PyMol or Chimera, whatever you have, you can see the model built using PyMol here, and you can compare it with the template. Already we have the template loaded in the Chimera. You just visualize our template alone and load the selected build structure based on the dope score. The 7th one is the best one. Open it and align using the Chimera. The reference structure is your template and the structure to match must be the build structure. Now you can see the alignment, how perfectly the modeler built the structure of your target based on the template with the RMSD of 0.1, which is very low and means both the structures are not deviating much. So, once this is confirmed, the structure the model building is confirmed, you can evaluate the same using the Ramachandran plot also. The modeler demo, you can load the 7th model and submit. Here you can see the Ramachandran plot with the phi and psi angles specified for each and every amino acids and the statistics. So, here the model was built with 98.4% of the residues are in favored region and 4% are in 4 residues are in that means 1.6% are in allowed region and there is no even single residue in the disallowed region. Means the model built the 10 conformations and we have selected the correct one and evaluated the correctness using the Ramachandran plot. So, it means the model what we built is very perfect and we can take it for further structure based drug designing.